Hey everyone, before we get into our lesson today, 5.1, I wanted to go ahead and go over some of the vocabulary that we're going to be using today and in some lessons to come. So the first word that I want to talk about is degree in terms of a polynomial. So degree will typically be abbreviated with a D whenever we're identifying the degree in a polynomial, and it's the largest exponent in the polynomial. So you look at the exponents on each term and find the largest one. Once we identify the degree, then we can talk about the leading coefficient. And the leading coefficient will be abbreviated as LC for leading coefficient. And that's the coefficient that's in front of the variable that has the largest exponent. So if we look at this example here of a polynomial, 5x squared minus 6x to the fourth plus 2x plus 5, I can identify my degree, again, by looking across all of the exponents and finding the biggest one. So 4 is my biggest one, and so this is our degree. Notice that this particular polynomial is not written in standard form. If it had been in standard form, that 4 exponent would have been in the first term. But this is still a polynomial, just not a standard form one. So that's the degree, and we would notate it as D is 4. The colon means is. We also want to take note of whether the degree is an even number or an odd number, because that's going to be important as we start graphing polynomials in our lesson today. So 4 is of course an even number, so let's just go ahead and write that. The other thing that we want to look at is our leading coefficient. So now that we know which term has the degree, this one right here, this is our leading term, the leading coefficient is simply the coefficient of that term, which is a -6. Be sure that you include the negative if there is one. So this is our leading coefficient. And again, I mentioned we would abbreviate that with an LC. And so for this, LC is -6. On this one, we don't care if it's even or odd. What we care about is whether it's positive or negative. And you'll see why as we get into things here shortly. But for now, let's just note that -6 is, of course, negative. All right, another thing that I want you to become familiar with is type of function. So type of function has to do with our degree. And so the type is going to be dependent on that biggest exponent. We have talked about several polynomials before, but you probably didn't consider them polynomials because usually we think of polynomials as being several terms. But we learned last time that it can be a single monomial. It's one or more monomials. So if our polynomial consists of just a number, a constant, then that's a degree of 0 because we don't even have an x or any other variable. If we have a linear function, the degree is 1 because remember, if we see an x in the equation, that x has an implied exponent of 1. Quadratic, you should be very familiar with that. We spent 2 whole 6 weeks on it, the second and third 6 weeks, and of course it has a degree of 2. Cubic is probably a new one to you, but it has a degree of 3. Just like a cube, if you're going to find volume, has 3 different sides that you need to take, length, width, and height. Quartic is 4. Think of 4 quarters in a dollar, quartic, quarter. And then finally, quintic is 5. If we get above 5th degree, then we basically just call it out by the degree. We would say 6th degree polynomial, 10th degree polynomial, etc. Now let's talk about some things that are going to be useful for us as we start graphing. One thing that we want to know about as we start graphing is our end behavior of our graph. What does it look like where the arrows are on each end as we show that things are going towards infinity or negative infinity. So end behavior. And so this is how the function behaves as x approaches infinity or negative infinity. And what that behavior is dependent on the degree and the leading coefficient. So let's take a look at what we mean by that. So the first thing we're going to look at is as x approaches infinity. So if you think about that, when x is approaching infinity, we are heading to the right. And so just to be clear, this arrow right here stands for approaches. And so as x approaches infinity, our f of x, our polynomial function, or our y value of our polynomial function, is going to approach something, either positive or negative infinity. We don't know until we take a look at our equation a little closer. The other thing that we'll look at is as x approaches negative infinity. And negative infinity would be going to the left towards smaller numbers. And we want to know what our function, what our y values are doing. Are they headed towards infinity or negative infinity? So I've put a blank right here, but for our particular function, we will fill in this blank. So we will fill in with an infinity or a negative infinity as it might be appropriate. So let's talk about how we decide if we fill that blank in with an infinity or a negative infinity. So when our degree, d, is odd, then our directions are opposite. One of our arrows on one side of the polynomial is headed up towards infinity and the other is headed down towards negative infinity. So the arrows are opposite. And when our degree is even, the arrows go the same direction. So either they both go up or they both go down. So the arrows are same direction. All right, now how do we know which direction is which? What's happening on the left side of the function? What's happening on the right? That is based on our leading coefficient, because very specifically our leading coefficient tells us about the right arrow. So specifically the right arrow. And if the leading coefficient is positive, then the right arrow is pointing up. And if it's negative, it's pointing down.